Lesson 18 is called Translating Functions, and before we get into what a translation is, we need to talk about what a transformation is. So, two different words, translation and transformation. The transformation is any change in the size, shape, or position of a figure in a plane. So basically, it's like an umbrella term for any change that you're making to a graph on a coordinate plane. And then moving down to the next section, what is a translation? So a translation is a type of transformation that shifts each point in a figure the same distance in the same direction. So you can have vertical translations, that's when you just move up or down. You can have horizontal translations, that's when you just move left or right, or you could have a combination of the two. So like say up and to the right or like down and to the left. So if we look at this example of a vertical translation, you're going to be asked to kind of determine what the translation is and how far. In order to do that, you want to focus in on a couple key points. So like on this graph, you can focus in on these 2 points. And you'll always be given kind of what is your starting function and what is your ending function. It doesn't say it on here because we're just kind of noticing the change in the graph. But if you notice, like let's say I take p of x, which is that blue function, and I just shift it downward. I move every single point down. It looks like 1, 2, 3, 4, 5 units. I get the new graph I of x. So every single point on p of x moves down 5 units to get I of x. So the other thing about translations is that the shape of the graph doesn't change. The like orientation, which is kind of the way it's facing or pointing, doesn't change. It really just moves it. So if you picture like kind of sliding something around, that would be a translation. And then a horizontal translation, horizontal just means moving left or right. So we kind of want to focus on the same thing here. We kind of zone in on a few key points to figure out how far we're moving our graph. So say we're starting with p of x again, and we're translating to get I of x. So I'm going to focus on that point at 0, 0. And that point looks like it moves over 13 units and ends up right here at negative 13, 0. That means all of the points on p of x are going to move 13 units to the left to get I of x. So like let's say this one right here moves over 13 units to the left. Let's say this point right here, same thing, moves over 13 units to the left. And what that does is it just shifts the graph to the left without changing the shape or the orientation of the graph. Okay, moving down to the next section. This is just going to be vertical translations, and we're just going to describe them. So as in like 4 up or 2 down. So example 1, describe the translation from p of x, that's the blue function, to I of x, that's the one in red. So same concept, we want to focus on a couple key points. So I think since these are parabolas, quadratics, we should just focus in on the vertex to start, which on p of x is at 0, 0. It's right there. So if I count how far it takes me to go from the vertex of p of x to the vertex of I of x, that's 1, 2, 3 units up. And then just check to make sure that they're all kind of, not all of them, but a few other points are also doing 3. It's just a nice way to check your work. So like if I count, this is going up 1, 2, 3 units right there. This point's moving up 1, 2, 3 units right there. And every point from p of x should be moving up 3 units to get I of x. So for this one, since we're going up 3 units, we would say translating or translate up 3. So translate up 3 units is how we get from p of x to I of x. Okay, moving on to example 2, describe the transformation from p of x to I of x. And it's really important to just always kind of check to see what's your starting function and what's your ending function. So it says like from p of x to I of x. So we're starting at p of x, the blue one, and we're going to I of x, the red one. So if we zoom in on example 2, These are both square root functions, so I think that like kind of starting point is a good point to focus on and see how that changes from p of x to I of x. So on p of x, that point is at 0, 0, and it moves down 1, 2, 3, 4 units to get the starting point on I of x at 0, negative 4. So since that went down 4, we're going to say translate down 4. And that means that each of the points on p of x also move down 4 units to get I of x. So we'll say translate down 4 units. So translate down 4 units to get from p of x to I of x, and then to look at these as a whole. Again, a translation is, or a vertical translation, is something that just moves the graph up or down. It's not going to change the shape or the orientation of the graph, like where it's facing or anything like that. It just kind of slides it. Okay, for the next section, it's horizontal translations, which horizontal just means moving it left or right. So we're going to do the same thing here, describe the translation from p of x to I of x. So example 1. Same structure here. We're starting with p of x, which is the blue function, and we're translating to get I of x. So we have another pair of parabolas or quadratics, so we should focus in on the vertex. So on p of x, the vertex is at 0, 0. And on I of x, the vertex is at negative 3, 0. So we're like, okay, well, how do we go from 0, 0 to negative 3, 0? I translated 3 units to the left. So each of the points on p of x are translating 3 units to the left, meaning they're just sliding over to get all of the new points for I of x. So for example 1, we'd say translate left 3 units. Okay, so moving all the points to the left 3 units from p of x to get I of x, so we're translating left 3 units. And then for example 2, describe the transformation from p of x, which is the blue one, to I of x, which is the red one. These are a couple of square root graphs. So on square root graphs, it's probably best to look in at those like kind of starting points. So on p of x, it's at 0, 0, and on I of x, it's at 4, 0. So ask yourself, how do I get from 0, 0 to 4, 0? I have to move 1, 2, 3, 4 units to the right. And so that means every point on p of x is moved 4 units to the right. And that keeps the graphs the same shape, just slides everything over. So we would say translate four units, or left 4 units. Oh, not left. I don't know my left or right. Translate right 4 units, excuse me. Okay, so to get from p of x to I of x, we moved all of our points to the right by 4 units. So we're going to say translate right by 4 units. And again, I know I've said it again, like over and over again, but translation means that we are keeping the same shape of the graph. All of the points are just sliding over. So example 1 in this section, we were translating 3 units to the left. Example 2, we were translating 4 units to the right. Okay, last section, last example. This is when we have a combination of 2 different translations. So we have a vertical and a horizontal translation. So example 1, describe the translation from p of x to I of x. So we have a pair of quadratics. I'm just going to go ahead and zoom way in on this. So we have a couple quadratics. Those graphs are called parabolas. And when we have those, it's probably best to focus in on the vertex. And that's the point where the graph changes direction. So on p of x, that's the blue graph. The vertex is right here at 2, 0. And then on I of x, which is the red graph, the vertex is right here at negative 1, 3. So we just have to figure out, okay, how do we get from that 0, 2, I don't know if I said 2, 0 before, sorry, but 0, 2 for p of x to negative 1, 3 for I of x. Okay, so you can see we got to go left 1. And then after we go left 1, we go up 1. So left 1, up 1 to get from 0, 2 to negative 1, 3. So we would just describe those both. So we'd say translate left 1 unit and up 1 unit. Okay, so to get from p of x to I of x, we're translating left 1 unit and up 1 unit. And then one more time, when you have two parabolas or what's just a parabola that's being transformed, you want to focus in on the vertex. Typically, it's usually the best one to focus in on. So on p of x, it starts at, or the vertex is at 0, 2, and then it moves left 1, up 1, to get to the new vertex, which is at negative 1, 3. So translate left 1, up 1, and then I swear this is the last time I'll say it because the video is almost over, but with a translation, the shape of the graph stays identical. And then next lesson, we're going to learn about a type of transformation that changes the shape of the graph.